Yeah. You're able to listen to my voice, all of you? Is my voice absolutely clear? It's clear, no? Yeah. Yeah, fine. Okay. So there is no audio and visual problems, right? Yes, hold on all of you. Not all the elements are synthesized. So today we are going to learn about your periodic table or the classification of the elements, right? So that's what is the topic which we are going to understand. And you realize there is lots of importance of this periodic table as far as chemistry is concerned, right? Whether you go for learning some concepts in organic or else inorganic, in fact, in physical also you will be like helped. So basically it's very, very important as far as this particular chapter is concerned. Okay. Now, so here the chapter which we are going to see, or else the topic for today is periodic classification of elements. Right? Now, I have asked you one question that there are how many elements in the entire periodic table? And I got the answer. What is the answer? It's basically 118. Absolutely correct, right? Now, the thing is, earlier your periodic table was not complete, right? There were certain, still unknown elements were there, right? Now, the thing is, we are talking about the current one beta, which is there in your syllabus, right? So the thing is, there are total 118 elements, and either they have been, synthesized or else they have been found. Okay, and accordingly, there will be names, right? So now the first thing is we must know where is the location, right? And it's my humble request to everyone in the session, please turn off your video. Yes, please turn it off. You're able to see me, you are able to listen to me. That's my humble request. Okay, now the thing is, for these 118 elements, we are going to see, you must know what is their placement, right? And basically, where they are. And accordingly, there will be like properties. Okay. Yes, Madhuri, what for you are asking why? Yes, people want to know where I am from. Basically, I am from Gujarat, right? And have got lots of experience in training many students for medical as well as JEE examination, right? So I have with me lots of experience, so need not worry about it. You are in safe hands, right? Now, without wasting any time, please, let us go further, right? Now, I told you that there are total 118 elements, right? Now, you try to see why there is a need of periodic table, first of all. The thing is, you can correlate this thing to basically if you visit supermarket, right? In supermarket, you see that everything will be organized. When you enter one section, there will be like some snacks section or some soap section, like that. Everything is organized. You can just ask, where is this thing? They will guide you where to go for, right? Now, imagine a scenario if the entire shopping mall, whatever is that shopping mart, if it is there, and it is kind of haphazard, right? So will it be easier for you to find out, or else, you would not like to enter that mart because you're not able to find anything, right? So that is what. So the things are organized and it's like easier for you to approach. Now, similar way, when it comes to so many elements, right? So the thing is, there are so many compounds. In fact, if you take carbon itself, there are millions of compounds, right? So if millions of compounds, that means what? There has to be some, like you need to study, if at all with carbon, there is millions of compounds that you are studying entire separate branch of organic chemistry for it. Then imagine the scenario with other elements, right? You are having so many elements, and if you keep on, if the scientists thought that one element will study, it will become difficult, right? So to make the the study of the properties of the elements more easier, they have been grouped together, right, into different groups and periods. Are we getting it? Now here, main purpose is basically your modern periodic table, right? Now this modern periodic table, tell me it is based on which particular property? Based on what? It is based upon atomic number. So basically, when you are arranging the elements in this periodic table, you are basically arranging them according to increasing order of their atomic number, right? Now, the thing is, how many groups and how many periods are there in the periodic table? How many groups and how many periods? There are basically 7 periods and 18 groups. Okay, good. So now we are going to learn, like, where is the placement? Did all of you know about like all the groups, the elements there? You know? Not exactly. Okay. So what we are going to do first is, the thing is, you are having, if at all you see the periodic table, it will be somehow like this. If you might have observed, right? Something like this will be there. I'm just drawing the framework of it, right? You'll be having something like this, right? Okay. Now the thing is, you would have seen 2 groups here, and then 3 to 12 groups here, 13 to 18 groups here, and basically here you will be having lanthanoids and actinoids, right? This is kind of a rough like grouping which is present in the periodic table, right? So what we are going to do is, first we are going to learn about these first 2 and then this 13 to 18, right? Now you just kind of consider this is basically roughly your entire periodic table is divided into 4 blocks, right? Now, why we are dividing that, you need not worry. It will be like, you will understand eventually, right? So you are having this 1 and 2 as S block, 13 to 18 as P block, 3 to 12 which you see, it is D block, and at the bottom which are there, they are basically F block elements, right? And the vertical columns which are there, basically they are known as the groups, right? And the horizontal rows which are there, there will be 7 horizontal rows. So 7 horizontal rows, they will be known as period, and 18 vertical columns, they are known as group. Are we getting it? And whoever is trying to create nuisance here, please keep your mouth shut. Right? Yes, you don't worry about that SPDF part. Don't worry about it. Right? Okay. Now the thing is, here let us go for group 1. Group 1 means we are talking about the S block, right? So basically, first group. So normally we are placing hydrogen in this, but hydrogen's place is still, what do you say? It is still not clear, right? Basically, group 1 is only for alkali metals, so it's better I avoid writing hydrogen here, right? So lithium, sodium, potassium, rubidium, cesium, and francium, right? So how you can remember this? It will be Lena. This is like you can combine these two. Lena knows rugby, chess, and frisbee. These are all the games. And a frisbee you might have played, when you were like this, what do you say? Small, right? And you might be playing with a disc-like thing comes, right? And you'll be like playing with that. Okay, so that's what is frisbee. So remember like that. Lena, you will be having lithium, sodium, potassium, rubidium, cesium, and francium. And whenever you are reading a particular block, right, or as a particular group, always try to, kind of take the name loudly so that you remember it. Okay. Is this clear? I have made this in English because majority of the students, they are from, that they can understand English more as compared to Hindi, right? Okay. Now, when it comes to group 2, so you are having these particular group elements here. So this one is beautiful mugs can serve badam rasmalai. This is the name of one sweet. So basically, beautiful mugs can serve badam rasmalai. right? Just give me a moment. Hemant, you don't know what is mug, huh? Wonderful. Frisbee is again a game. Yeah. Right. So are you able to see this is beautiful mugs? Mugs, you already know, no? Coffee mugs will be there, right? So this is beryllium, magnesium, calcium, strontium, barium, and radium, right? Getting it? All of you? Are you writing along with me? And whenever you are revising, please make sure that you are writing and also reciting the name of these elements, right? So Lena knows rugby. Rugby is again, you know, you might have seen an elliptical ball, right thing, football, similar to football, rugby, right? A sport, correct. Then you are having chess, you already know. Frisbee is again a kind of, you know, circular disc-like thing, and people will be standing in a circle, right? And you'll be like playing with it, right? Maybe in your childhood days, you might have played. Yeah, right? Okay, good. Many people know about it. Can we go further? Can we go further? Yeah. Okay. Now, next is group 13. Now, in group 13, what you are having is these elements. So, this one you can treat like this is Bal Ganesh. Bal Ganesh. Or else if you want to write it separately, you can write separate also. So, this is Bal. Ganesh. Bal is for small kids we use, right? Bal Ganesh in Thailand. Or else you can remember like there is a brand of the bag which is Baggett. So either way you can go for. Now here you are having boron, aluminium, gallium, indium and thallium. Yes, Nilash, please turn off your video. Yes, it is thallium in the end. It's thallium in the end. Right? Group 14. What you are having here is this one is carbon, silicon, germanium, SN and PB, right? Now, this one you can remember like chemistry, sir, gives centi problems, right? Okay, so this is carbon, silicon, germanium, tin and lead. Clear about it? Can we proceed further? Centi is emotional. Have you noted down? Have you noted it down? And you have to remember it also. And see if there is any other mnemonic which you are having, most welcome, not an issue, right? You can learn that. Okay. Right. Now, next is group 15. So this is Nani, you already know, hai na? Start from here. Prabhas, right? Aishwarya. Aishwarya Rai, all of you know. Sub. Sub means all. Sub is Hindi word which means all. Big stars. Right? Nani and Prabhas, I need not tell you because already you people know, right? And what you are having is Aishwarya Rai, AS, A stands for that, right? And all, big star, bismuth. Now, what are the name of these elements? Nitrogen, phosphorus, arsenic, antimony, bismuth, right? So you should repeat actually. When I'm teaching you, it's better, kind of recall the names of these elements, right? So you are having nitrogen, phosphorus, arsenic, antimony, and bismuth, right? Now, let's go for group 16. Group 16 is oxygen, sulfur, selenium, tellurium, polonium. So you can think, oh, Salman Khan, selling teapots. Right? Salman Khan is again a big star and people will be, kind of shocked to see that he's selling this teapots, right? So whenever you are kind of, making any mnemonic, so it should be something like, which is quite funny or else it is a kind of good story by which you kind of remember the things. So it will be like good for you because if you are able to relate to the concepts, so there will be there in your memory for longer time, right? Written all of you? So this is oxygen, sulfur, selenium, tellurium, and polonium. Yes, you don't worry about livermorium, beta. We will learn it horizontally, right? You don't worry about it. PO means what, beta? Polonium. Are we done? SC, selenium. Selenium. Oxygen, sulfur, selenium, tellurium, polonium. Right? Okay. Now, next is group 17. So this is first class biryani. All of you love biryani, right? In Atlanta. Right? This is the name of one city in US, right? So you are having fluorine, chlorine, bromine, iodine, and astatin, right? This is astatin. Right? Fluorine, chlorine, bromine, iodine, and astatin. Yeah. Group 17. Now, group 18. Right. So this is Hina, this is Nina or Karina. These three are friends actually. Hina, Nina, and Karina. Or is nothing but and in English, right? X-ray, or else you can remember Xerox. Or else you remember X-ray, not a problem. Rangeen. Rangeen means colorful. Right? Hina, Nina, or Karina, they are three friends, right? Group 17, this is fluorine, chlorine, bromine, iodine, and astatin, right? Group 18, you are having helium, neon, argon, krypton, xenon, and radon, right? Yes, oganesson is also there. Oganesson is also there, but few of the new of the elements I have not included here. Oganesson. Yes, finish writing all of you, group 17 to 18. Ria, if you remember better, not an issue. If you remember it, good, no problem, right? If you are already remembering by a particular way, that's okay, absolutely fine, right? XE means xenon. Are we done writing it? Tell me. So what we have finished is, we have finished first two groups, group 1, group 2, which was on the extreme left side. Then we have moved from group 13 to 18, which is always on the extreme right side. Now we'll be going for D block elements, right? Somebody is just asked D block element, right? S and P block is done. Now we'll move towards the D block elements, right? Now, for D block elements, right, I am writing 3D transition series. Now you understand one thing, I'm calling this as 3D transition series. Now you need not worry about this, right? AS is arsenic, okay? 3D transition series, 4D transition series, and 5D transition series. Now you understand the meaning of this word transition, right? Now what we are having here is, this is the kind of periodic table which you have seen. Here we had S block. Here on the extreme right, you are having P block. And here you are having D block, right? And eventually, as you grow mature in the subject, you will understand, you will come to know that S block, they are very reactive metals, right? Here, P block, as you proceed from left to right, non-metallic character increases, right? So there is a kind of transition from the metallic behavior to non-metallic behavior. So there is a kind of transition which is happening. That's the reason we call it as transition series, right? And at present, you need not worry about 3D. You just take it as 3D. Getting it? But it is not three-dimensional. It's 3D. D represents the orbital there. Okay. Is this much clear? I'm telling you only information which is required at present. Okay. Now, for 3D, you are having this. It starts with scandium. So what we are having is, this is Sachin. Sachin Tendulkar, all of you know, right? So Sachin Tendulkar, very crazy man. Why he is crazy? Because he gave free coaching. To whom? To Nikki's cousin. Right? So that's why people call him crazy, right? So are you able to understand mnemonic first? I have not taken the name of the elements, need not worry about it. I'll definitely tell you, right? So this is Sachin Tendulkar, all of you know about him, right? Who doesn't know about him basically, right? Now, then Sachin Tendulkar, very crazy man. Why people are calling him crazy? Because he gave free coaching. Because cricket coaching is very difficult. Like any sports coaching you go for, it's very, very costly actually. So that's the reason they are calling. He might have seen some kind of talent in Nikki's cousin, right? So what he has done, he has given free coaching to Nikki's cousin. Now, when you take the name cousin, in that you are having copper and Zn kind of sound which is there. So from there you can remember, right? Nikki's from there Ni, nickel, right? Now, I'll take the name of these elements. So you are having scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Right? And when I am saying it's better, you also kind of repeat so that it will be clear for you, right? So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. Chromium, CRS chromium, right? Cobalt, nickel, copper, and zinc. Yes, good. Good, Ria. See, the thing is, still, you will definitely remember. Okay. Yes, I'll tell you what is 3D. If you know about SPDF, then you will be able to understand about this. And basically, somebody is asking about the group number, right? So their group number is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? Remember, I have left some gap in the periodic table like this for explaining you. 1 and 2 was this. 13 to 18 we have seen. 3 to 12 was this. Yeah, you learned? Very good. You learned, it's very nice. Yes, please hold on your curiosity for SPDF. Definitely, I'll teach you. Don't worry about it. Okay. SPDF, I'll definitely teach you. First, you learn the periodic table, right? I hope everybody has written this. Now, next is 4D transition series. Now, for 4D transition series, right? Now again, the same group number is there. Right? Now here, this is yes, zebra. I'm writing those things in bracket just to complete the statement. Okay. Yes, zebra can never be molded technically into is just to complete or make some sense, है ना? Into rude rhino. Rhinoceros, all of you know, right? Provided given silver Cadbury. Right? So the thing is, there are two different organisms which we are talking here. One is zebra, another one is rhino. Both are absolutely different, right? So you cannot mold one particular, mold means, the thing is, you might have seen different cupcakes and all those shapes will be coming. No, your mother might be making at home. Molds will be there, right, of different shape. So here also we are talking about that kind of molds, right? So basically you cannot technically convert your zebras into the rhino. And how are those rhinos? They are like very attacking in mode, right? So basically technically into rude rhino. And technically, unless and until you give them silver Cadbury, normally we'll be like all loving those chocolate, you know, Cadbury, Dairy Milk we love. But if at all you give this rhino, this particular, or else you give the zebra, the silver Cadbury, it might get molded into the rude rhino. Did you understand the mnemonic? And if at all you are having anything with you, like any other mnemonic, fine, well and good, not an issue, right? Now, coming to the name of this is yttrium. Y for yttrium, right? Now, ZR for zirconium, NB for niobium. I'll repeat these three. Y for yttrium, ZR for zirconium, NB for niobium, MO for molybdenum, TC for technetium, ruthenium, rhodium, PD for palladium, AG for silver, CD for cadmium, right? Now, next is 5D transition series. Now, for 5D transition series, you are having these elements, right? And here I am purposely not writing there, kind of atomic number, right? Y is for yttrium, beta. Shanmukh, it is for yttrium. Yes, all 3D, 4D, 5D, 6D, all these are D block element. Your D for D block, right? Y is for yttrium. So now here, this you can write as latest half talking women researched, right? So because of that, Osama, he got irritated. So he has put gold in mercury. This is mercury. Right? Try to understand this mnemonic. The thing is, normally, always women are also always associated with chatterbox, right? And if someone has discovered that there is some women who talks like just half the amount, so it is a kind of relief for people, right? That happens, right? People can relate to it. So now the thing is, so that was told to whom? To Osama, right? So Osama, what happened to him? Somebody told him that there is like latest half talking woman who has been researched in a particular lab or something like that. So he got so irritated, right? Osama got irritated. So what he did, he has put gold. Gold is a very costly material, right? Costly element. So he has put that gold in frustration or in irritation into the mercury, right? Mercury is Hg. So I hope it is clear to you. So basically this is lanthanum, La for lanthanum, HF for hafnium, Ta for tantalum, W is for tungsten, this is rhenium, this is osmium, Os is for osmium, Ir for iridium, Pt is for platinum, Au is for gold, and Hg is for mercury. Yes, Reena, you are supposed to know all these elements. In fact, when you enter into 11th and 12th, basically you will be studying about the properties of all the S, P, D, and F block elements. Ruthenium. This is ruthenium. This is rhodium. Rhodium. Yes, clear about it? Now, 6D transition series. So in 6D transition series, we are having all the newly discovered elements. So this one will be 104, 105, 106, 107, 108, 109, right? So basically, I'll tell you up to this, right? One trick which we have made here, right? W is tungsten. Modern periodic table is a graphical representation of Aufbau principle. No, we don't say like that. Definitely, it is like the filling of electrons takes place according to the Aufbau principle, right? Now see here, somebody was asking me about 5D transition series. See, I told you that Osama is a person, right? Now, to that person, somebody told that there is some latest half-talking woman who has been researched somewhere, right? And it is a kind of wonder, or else, kind of he thought that this thing could not exist, right? So if it is existing, he got irritated, and in that irritation, what he has done is he has put gold in mercury, right? Yes, Meghna. Okay. Now, the thing is, here for 60 transition series, in fact, I have divided it. You are able to see I have put a bar here, right? And after these elements, there is again a kind of, new more elements which are there, but they are not part of basically 60 transition series, right? So basically up to this, I'll tell you, and then you can have in the continuation. So here you can remember, actually, RF is Rutherford. Actually, Rutherford dubbed a song. BH, you can remember behind. Normally, you remember, if at all we are writing some address. So behind, if at all we are writing, it will be B/H we will be writing. So that is behind, right? Behind his metro. And where is his metro? That metro is in Darmstadium. Right? So you understand this. So Rutherford is the name of the scientist, and I've tried to keep those names intact like this. You're having this, actually Rutherford dubbed a song. Is in bracket. That means just to make sense of the statement. So actually Rutherford dubbed a song behind. Where did he basically dubbed a song? He dubbed that behind his metro, right? Where is that metro? Metro rail, all of you know, na? So behind his metro in Darmstadium, right? Now, you listen to the name of the elements. This is actinium. This is Rutherfordium itself. Dubnium, that's why dubbed. Seaborgium, again the name of the scientist. Borium, right? Then you are having hassium, metnarium, Darmstadium, right? Getting it? Not now, later on. 3D and 4D we have already seen. Right? So basically this is from 89, and then from 90 to 103 you will be having basically F block elements, and here you are having 104. This is 105, 106, 107, 108, 109, 110, right? Now I have purposely not written for this because there is again in the continuation. Seaborgium, Sg is Seaborgium. AC is actinium. HS is hassium. See, at present, you people don't worry about much of the name of these elements. Don't worry about it, right? Eventually, you will learn. Don't take much of the pressure. Are we getting it? At least you should be, at this particular stage, at least you should be thorough with the S and P block. And D block at max. And in D block also, last line which is there, no problem at present, right? Now, next what you are having is this Rg and Cn. So I'm writing here, RgCN. So this is basically 111, 112. Right? And this is 113, 114, 115, 116, 117, and 118. Right? Now, all of you know Roger Federer? He's also sports legend, right? Hitesh, I already told you, beta, that it is seaborgium. And I'm already telling you, for the name of the new, very new elements, you need not worry. Eventually, as the course will progress, you'll be able to understand, right? So at present, at your level, since you are, very new to this periodic table, so the thing is, you just remember at least S block, P block, and 3D, 4D, 5D. That is sufficient at present. Getting it? I'm telling you, but that's okay. Only it will come by practice when you're writing, right? Writing and, kind of telling the names of these elements aloud. Okay. So Roger Federer can never have flavor of masala chai. Why? Why he can never have? Because masala chai is available in India only, right? So, as he lives where? In Tennessee, right? And this, oh God, right? So basically, Rg is for Roentgenium, right? So up to this Rg and Cn, they are part of 6D series only. They are basically 6D series elements. But I have made one so that it can go across the period, right? Now the thing is, this is Roentgenium, Cn is Copernicium, NH is Nihonium, Fl is Flerovium, from their flavor, right? Moscovium, MC. LV is Livermorium, right? Then you are having Tennessee, right? And again, Oganesson. Need not worry about the name of, kind of the new elements. Eventually, you will remember, okay? Tennessee and Oganesson. Are we done? F block at present, I'm not telling you. This much you remember, that is sufficient at present. Okay. Eventually you will learn, right? Now, people are asking about SPDF. And the thing is, for knowing the periodic table, you must be kind of, aware of it. Okay. Now, basically, these are the 4 orbitals. And normally, you already know where are like, yes, you want some time to write, Haripriya? Definitely, I'll give you better. Which particular portion you were writing? Raj and Haripriya, they asked, ma'am, give us some time. Which one you were writing so that I can give you some time? Or else maybe you can later on have that, I'll give you that QR code, if that is okay with you. Done? Yeah, okay, good. Now, the thing is, I'll give you a brief idea about SPDF, but because unless until you know about it, you will not be able to feel comfortable with the kind of placement, where are these elements placed and why we are calling them as SPDF, right? Now, the thing is, here what we are having is, first of all, you learn SPD and F. These are the name of the orbitals, right? Till now, what you know, That is basically you are having your electrons where? Where do you think your electrons are? Yes, I am asking you, don't worry. Till now, you know that there is shell, right? Now, when it comes to, like when you are like entering into 11th, you will definitely hear of a name that is basically orbital. So orbital is a place where you find the electrons. And there are 4 types of orbital. Orbital is just the name, right? Where there are 4 different types of orbitals named as S, P, D, and F, right? Is that clear? Okay. And here itself, you will be able to find the electrons. Okay. Now, the thing is, you must know how do you fill the electrons here. Okay. Yes, Dheeraj, can you please hold on beta for some time? I have seen your query. So please don't be impatient. I'll definitely answer that. Okay. Now the thing is, we already know about shells. Shells are only your orbits, right? Okay. Now the thing is, when we talk about S, P, D, F, these are the orbitals in which your electrons will be going. Now for S orbital, what we take is, we just draw one box. You're able to see S orbital, we represent for the electronic configuration as just one box. I'm not telling you any kind of, its shape or something like that. Because S orbital, you will learn that eventually it is spherical in shape. P orbital will look like something like this, right? Dumbbell. So I'm not going into those details. I'm just telling you that particular portion by which you will be able to understand the filling of the electrons, right? Now, so S is like this. For P, basically you will be drawing 3 boxes, right? No, there are like for SPDF, again, there is like GH like that, it will be there, but of our use, it is only SPDF, right? Now, for D, how many boxes? You'll be making 5. For F, how many boxes? 1, 2, 3, 4, 5, 6. There are total 7 boxes, right? And just remember, the capacity of one box is 2 electrons. How many? In one box, how many you can keep? 2 electrons. So do remember this. I'm just telling you the very basics of it. Okay. S, P, D, and F. S we represent by one box for writing the electronic configuration. P 3 boxes altogether. D 5 boxes altogether. And F 7 boxes. Right? You're able to see 1, 3, 5, 7. All the odd numbers are there. Right? Now, in one box, you will be able to put 2 electrons. Right? And we'll be writing like this, opposite spins we say, like this way you represent, right? So basically, again here, how many? Maximum 6 electrons. How many here? Maximum 10 electrons. How many here? Maximum 14 electrons. Clear about this? One box, it has the capacity of 2 electrons. So 3 boxes collectively 6 electrons, 5 boxes collectively 10 electrons, and 7 boxes it will be 14 electrons. Are we clear about this? Absolutely. Okay. Now, basically, there is different types of orbitals here, right? Now the thing is, you are having, I'm going to draw like Aufbau principle or else Aufbau chart, which will be helping you to write down the electronic configuration. So at least we'll practice electronic configuration for few of the elements so that you get comfortable, right? So what we are having is 1s, right? So you make it a circle, or else if you don't want to put a circle, no problem. You write 1s at one level, 2s, 2p, 3s, 3p, and 3d, right? Then you write 4s, 4p, 4d, and 4f. And mind well that I'm keeping a proper gap between these, right? Now, then you are having 5s, 5p, 5d, 5f. Then you are having 6s, 6p, 6d, 7s, 7p. Right? More than this, we do not require. Okay. Now, let us see how do you remember. Okay. Now imagine that these are basically balls. You're able to see, normally you'll be playing with the balls and you'll be hitting on basically a wall, right? So imagine that ball is hitting and it is going back, right? You're able to see that. And again, it is coming like this. Again, it is going back. Are you able to see? So I'm drawing it diagonally. If you're able to see carefully, like this diagonally, all which are there. right? Like this it will be. Right? Now the thing is, this is basically going to give you the energy levels, right? So first what you're going to write is 1s. After that, where the ball has kind of hit, it is 2s, right? I'm writing the energy, energy levels. So 1s, after that it is 2s, and after that it is 2p. You're able to see 1s, 2s, 2p. After 2p, what will come? Why are you bothered about the name of any chart? In the examination, nobody is going to ask you about the name of the chart. What is being taught here? Please pay attention. It will be 3s. After 3s, what you're able to see? It will be 3p. After 3p, what should be there? 4s. After 4s, what should be there? 3d. Are you able to see that? Okay. Then after that, what will be there? 4p. After that, 5s. After that, 4d. After that, 5p. After that, 6s. Right? Basically, I'm just writing whatever is visible on the board here. Right? Yes, it's audible, beta. Maybe check your system. Is my voice audible to everyone? Yes, correct. And you need not worry. Basically, the thing is, eventually you will learn this, right? Eventually, with practice, it comes. 6s. Then after that, 4f. Then you are having 5d. Then you are having 6p, 7s. I'm stopping up to this point. And you don't get terrified by these orders, okay? You will definitely remember it. Maybe check your connectivity issue, but there could be a problem, right? Okay. Now see here, how did we can even justify this order? Basically, Aufbau principle, what he said, basically, the thing is, according to Aufbau principle, see, normally what happens is when you are climbing staircase, right, anywhere, so you won't be jumping from 1st to 10th, no? You'll be first going to the second one, third one, like that. You can, at max, you can just one more stair, right? But you cannot jump, you cannot have a very high jump. Otherwise, you might fracture your leg, right? So the thing is, eventually, when you are going slowly, you are moving towards higher energy level, right? So here also, the electrons basically tend to enter into lower energy level first and then the higher energy level. Now, how do we say that these are basically the energy order? And it has come from N plus L rule, right? Now, what is that N plus L rule? Now, you see, this N is telling you shell, right? Shell means your orbit, okay? Now, N is basically, we call it as principal quantum number, right? Now, you just do not get confused on, kind of overburdened with any name. Just remember, this is a name of N. And quantum numbers, what do we require quantum number for? For reaching up to the electron. Normally, if at all you order anything on Amazon or Flipkart, what you will be doing is, you will be writing the address, first your name, right? Then what is your house number, which locality it is situated in, which city it is in, right? And then which state. That's how you kind of write. And that's how people, or whatever order you have done, that will reach up to you. So similar way, just think quantum numbers are the tools. Or these, like there are 4 quantum numbers basically. And using those quantum numbers, you basically come to know about everything about the electron, right? So 2 such quantum numbers are N and L. Are you getting it? Right? And L is basically your azimuthal quantum number. You just remember the name. L tells you about the subshell, right? And this is basically azimuthal quantum number. So you just remember like this: shell, subshell, and orbital, right? So you can consider, like, if at all you are not able to kind of, relate to all these terminologies, you think like, suppose there is a building, right? And treat that building like an atom, right? Now, there will be like many floors in that building. So each floor is basically shell, right? Are you able to relate this? Now, in one floor, there will be again so many shops will be there, no? So that is basically subshell. And suppose in a particular room, you have put some kind of partition. So think of orbital. So atom, shell, subshell, orbital, right? Now, somebody, again, if at all you are reading this for the first time, I'll just tell you one thing. So we have written like 1s, 2s, 2p on the same level, 3s, 3p, 3d, 4s, 4p, 4d, 4f on the same level, 5s, 5p, 5d, 5f on the same level, 6s, 6p, 6d, 7s, 7p. Right? Now, what we have done is we have imagined a ball which is hitting this wall and going back, bouncing back and again hitting across 2s. Right? Are we getting it? So that is how we have made this order. And in fact, you can justify this order using this n plus L rule. Now, you must remember one thing. If n is equal to L, 1, so this is basically first shell. And first shell means you have studied about K shell now. All of you know about this. N equal to 2, second shell. And that is basically L. Then N equal to 3, it is third shell. And that is M. Are we getting it? That's how it continues, right? Yes, there is 8 also, beta. It is there. Now the thing is, you don't require to fill up to that level. That is the reason I have stopped at 7s, 7p, right? Achha, this one you are not able to read, Ria. This small L I have written. This is azimuthal. Azimuthal. That is the name of it. Azimuthal quantum number, right? Now, next L value, right? Value of L and the subshell. Right? If value of L is 0, it is telling you S subshell. If value of L is 1, it is P. If value of L is 2, it is D, right? And if the value of L is 3, it is F. So at present, you just take care of this N and L, right? L equal to 0, it is for S subshell, L equal to 1 for P subshell, L equal to 2 for D subshell, and L equal to 3 for F subshell. Yeah. Now, the thing is, let us see how this N plus L rule works, right? Now we have written 1s and 2s. Yes, we have written 1s and 2s. And we have also written one more thing here, if you see carefully. And I will come back to that. First, you just see this. Now, what is the N value? This number which you are able to see now, that is the N value. So N will be 1. Yes. Now tell me, what is the N value here? What is the N value here? It is 2. Good. Now, are you able to see S? If it is S, what will be the value of L? It will be 0, correct? Here also it will be 0. So what is the value of N plus L? It is 1. And what about this? N plus L equal to 2. Now N plus L is directly proportional to the energy. Higher is the N plus L value, higher will be the energy. That's the reason your electron is first entering into 1s and then after that it is going into 2s. Did you understand that? Right? Now similar way, you go for checking for 2s and 2p. Right? What is the N value? N value is 2. Here also N value is 2. What about L value for this one? What is the L value for 2s? Correct. Good. What about L value for this P? It is 1, right? So what is N plus L value here? It is 2 and N plus L value will be 3 here. Which one will be higher in energy? Energy wise, this will be higher. Right? Clear about this? Which one, Ganesh? Which one you didn't understand? Tell me. Which one you didn't understand? N plus L rule. Definitely, I'll explain you. See, the thing is, you just read N and L. There are basically 4 quantum numbers, right? And out of that, we are taking help of 2 of the quantum numbers. One is N and another one is L, right? Now, the thing is, your summation of N plus L gives you idea about the energy of that orbital, right? If higher is the energy, if higher is the value of N plus L, we say that higher is the energy, right? Now, so if at all you see this numerical part which is there, it will tell you which shell it is, right? So it is N equal to 1, right? Now I have written S. So you have to remember this value. Without that, you will not be able to understand. If value of L is 0, it means S subshell. If value of L is 1, it is P. And if value of L is 2, it is D, right? Okay. Now, So because of that reason, since it is S, I have written L as 0. Here also S, so L is 0. So just club them together, right? Whoever is asking about L, see, the thing is, in quantum numbers, you will learn better. Now you just focus on what is the applicability of these things here. You will eventually learn, right? So here for P, we have written L as 1. So I hope, Ganesh, this is clear. Yeah, I'll come to that. What you are having is 2P and 3S, somebody is asking, right? Now tell me, Ganesh will answer. Ganesh, you have understood, right? Now you tell me, what is the N value here for 2P? Nobody else will answer, only Ganesh. What is the value of N here? N beta, N, not the L value. I'm asking about the N value. N is the number which you are able to see there. So it is 2. Definitely L value is 1. If at all you are meaning 1 by L, right? So what is the N plus L value here? 3. What about this? N will be 3, L will be 0. For S it is 0 now. So N plus L, that will become what? Here also it is 3. Now that doesn't mean that if the value of N plus L is same, that means the energy level is same. We can't say that. So in such cases, when the N plus L becomes equal, right? In that case, what we do, the electron will enter into that orbital which is having lower energy level, right? So here I'm saying that if N plus L value is same, then electron enters into that orbital which is having lower N value, right? Now out of 2P and 3S, where your electron should enter? Where your electron should enter? 2P, right? Because N is equal to 2, which is smaller than 3. Clear about it? Now same funda is applicable for 3D and 4S also. 3D, 4S, right? Or in fact 3P, 4S if you apply. You are having 3P, 4S and you are having 4S, 3D. So for this, if you see, N is 3, L is 1. Here N is 4, L is 0. So N plus L is what? 4 here. Here also N plus L is 4. Now where the electron should enter first? 3P or 4S? 3P. Very good. So electron will enter first 3P. Now talk about 4S and 3D. Here N plus L is 4. Here what about this? N is 3. What about L value? What about L value here? For D, L value is 2. So N plus L will be 5. So where the electron should enter? Where the N plus L value is less. That's why first in 4S, then in 3D. Getting it? All of you clear about it? Yes? Yes, I'll repeat. What you're having is, I compared between 4S and 3D, right? In 4S, what is the value of N? N is 4. Number you are able to see the 4. Now, if S is there, L will be equal to 0. And what about N plus L? It will be 4. When it comes to 3D, what is the N value? Number which you are able to see? It is 3. Right? And then, what is the value of L here? 2. So basically what you are going to have is N plus L as 5. Done? Clear? See, for some of you, it might be slightly difficult to relate to this thing, but do not worry. I'm just teaching you some of the portion, and once you know, kind of you learn about in atomic structure entirely, then you will definitely understand it, right? Don't worry about it at all. Able to see N plus L. Lesser N plus L value, energy is less, so the electron will enter into that first. And after that, it will enter into the higher energy one. And what if N plus L becomes same, then in that case, whichever N is small, the electron will enter there. Is it clear, all of you? Is it clear? right? So all you need to remember is this particular thing, you know, this order. And in fact, I would tell you, you just remember up to certain point, not much. Okay, don't kind of overburden yourself. At least you remember up to 3D 4P. Up to this you remember. What you are having is 1s, 2s, 2p. Then after that 2D is not there, 2D does not exist. Then you are having 3s, 3p, 4s, 3D, 4p. At least you remember this. Are you getting it? You just remember up to 4p. And you know, I definitely promise you that the thing is, if you keep on learning, now the thing is, we are just telling you some portions of it. And when you come in 11th class, you'll be learning about the atomic structure in detail, right? There will be quantum numbers and all the queries will be answered. Now here, I am just telling you that particular portion, which will be utilized for, you know, kind of understanding the filling of the orbitals or the electronic configuration, right? Now, let us kind of just practice some here, right? For your, you know, kind of ease, I'm writing 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, right? I'm just writing only these. I'm not writing much. That's how energy increases. Are you able to see this? Right? Now, we'll be writing some of the configuration. Quantum numbers is the name, right? And quantum physics will be there, quantum chemistry will be there, which is a very typical line to study, right? Okay. Now, here basically 1s, 2s, 2p, 3s, 3p, 4s. Now the thing is, suppose I am having hydrogen. Hydrogen, how many electrons it has? Only one electron, right? So where it should go? It should go into, I'm writing the electronic configuration. EC is electronic configuration, right? So hydrogen 1, so where it should go? 1s1. Are you able to see what I'm writing? 1s1. 1 will be on top of it, right? Now you always remember s orbital means 1 box. Do you remember that? 1 box means what is the capacity of the electrons there? At max 2. Very good. If I'm writing p, whether it is 2p, 3p, 4p, 5p, whatever it is, how many boxes would be there? 3, right? For 3, what should be there? 6 electrons, right? Now, if at all I'm writing D, then in that case, maximum 10 electrons. F, then in that case, maximum 14 electrons, right? Now, helium, you tell me, all of you, helium is 2. If helium is 2, next electron, where it is going to enter? Capacity is 2, right? So it will go in 1s2. Now, next is lithium, where the electron is going to enter. First of all, 2 electrons in 1s2. That is full. After that, 1 more electron, it will go in 2s. Are you able to understand? Everybody is on the same page or not? Yes? Good. Now, next is, you are having beryllium. Beryllium is 4. So what you will be writing? 4 electrons means first 1s2, 2s2. Now you do one thing. I'm giving you some. Please write it. Just for the practice, I'll definitely write. And I'll do one thing. I'll basically bring this here so that you are able to see the order and you are able to fill it up. You don't type. The thing is, I can understand it's difficult to type, no problem. You just write down in your notebook. And once I write here, you just kind of, match up with the answer, whether you were able to do it correctly or not. Right? Yes, Ria, please don't type better. Okay? You write it. All of you, I am giving you these few so that, you kind of understand the kind of how do you write down the electronic configuration, which is required for, kind of knowing the understanding of the filling of the electronic configuration as far as periodic table is concerned. How many of you finished? Yes, many, I think. Still, anybody is still writing? because I want everybody to, kind of do this exercise. Okay. Now the thing is, for boron, you tell me here 1s2, 2s2, capacity is full now. Now in case of boron, there is fifth electron. Where it will go? It will go in 2p. So you'll be writing 1s2, 2s2, 2p1. When it comes to carbon, you will be writing 1s2, 2s2, 2p2. Then 1s2, 2s2, 2p3. 1s2, 2s2, 2p4. Then 1s2, 2s2, 2p5. 1s2, 2s2, 2p6. Able to understand why I went on from 2s1 to 2p6? Yes? How many of you did all correct, beta? From boron to neon? Yes, very good, wonderful. Right? And at initial stage, if at all you are making one or two mistakes, it's absolutely fine. You need to learn from your mistakes, right? So that you don't repeat that in the main examination. Yes? Okay. So now you understood this. You're having neon, then you're having sodium. Write it for this. I'll write few more elements here. You write it. And I'll again write down the energy order because it may not be visible to you. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. No, this is not another type of configuration. Abu, which configuration you are talking about, beta? Are you talking about 2881 like that you are talking about, which you have learnt in your 10th class? Are you referring to that? Yes. Now the thing is, we'll justify that also. I'll definitely tell you that. Don't worry about it. First, you write this. In fact, you might have seen, see, for oxygen till now, what you would have written is, you would have written 2,6. Remember? Yes. So in the first shell, it is according to shell wise you used to write, right? So you are having this first shell, 2 electrons. Second shell, how many electrons? 6. 4 plus 2, 6. Are you able to see? Yeah. Right? Again, for neon, you would have written 2, 8. Right? So that is according to the shell. In the subshell we are going and in the orbital we are reaching, right? So here how many electrons you are writing? 2. And here how many? 8. That is, are you able to relate now? Yes, Abu, are you able to relate? Yes, 1s, that particular orbital is in the subshell. Subshell or orbital you talk about. Clear about this, right? Okay, good. Now you do one thing. I have given you few here for the practice. Please do this and then I'll discuss it. And in fact, I'll include a few more. So here it is 11, 12, 13, 14, 15, 16, 17. Argon is 18. Potassium is 19. And then calcium is 20. Scandium is 21. Titanium is 22. Only to give you a feeling of like basically up to, kind of involving the D also, I've given you titanium. In fact, I'll give you Mn also so that you get more feel of it. 25. As a sodium, you want to understand, okay, no problem. Somebody wants like I should write for sodium first, no problem, I'll do it so that you get an idea. Now see how many electrons are there in sodium? There are 11. So first of all, how many electrons will send to S? It will be 2. Then next, how many electrons to 2s? Again 2, right? So how many done? 4 electrons, no? 6 more you can send in P. So total how many done? 6, 7, 8, 9, 10. How many electrons are less in comparison to 11? It is only 1 electron. So where you will send that? In 3s. Yes? If somebody has kind of, worked very hard for, kind of writing all those configuration, I appreciate that effort. But the thing is, I would really appreciate that it's better you write down in your notebook, right? So that basically because definitely it's very difficult to type on this particular chat box, right? Highly impossible, next to highly impossible task. So it's better you write down in your notebook. And once, we are kind of writing it, and you can then verify it. Yes, Mn has 25, beta. Mn has 25. Okay. Now tell me for magnesium. Yes, somebody has asked me about sodium. So now keeping that in mind, go for magnesium, aluminium, silicon, and all those things. How many of you finished, beta? How many of you finished? Okay. Now for magnesium, there is 12. So where will be the next electron? In 3s2. So we'll be writing 1s2, 2s2, 2p6, 3s2. Will I ever be writing 3s3? Will I ever write 3s3? Will I ever write 3s3? No. Right? Good. Now for aluminium, where I'll send the next electron? 1s2, 2s2, 2p6, 3s2. Next is 3p. I'll write down 1. Right? Okay. For silicon, what I should write? 1s2, 2s2, 2p6, 3s2, 3p2. Maximum capacity of p orbital is 6. So definitely it can take lesser than 6, right? Now for phosphorus, 1s2, 2s2, 2p6, 3s2, 3p3. Did we write like that? Yes. For sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. Good. For chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Did we write like that? Which one, Rajendra, you are not able to understand, beta? Tell me first. Which one you want to understand? See, P can have 6 electrons, beta. About shells. Filling of the shells you are not able to understand. We'll do one thing. For argon, you tell me. See, the thing is, till now, what you have learned is only you'll be writing 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, like that you are writing, right? So you pay attention here. In case of hydrogen, till now you might have just written like this, 1. Here you would have written only 2. Here what you would have written, 2, 1. Why you have written 2, 1? Because in the first shell, n equal to 1 is first shell. N equal to 1, basically first shell, how many electrons? 2. In the second shell, how many electrons? Only 1, right? Preeti, hold on, beta. Here people are not able to understand some very basic things. So let me explain that, and definitely we'll come to chromium. Don't worry about it. Now here, for beryllium, you would have written till now 2, 2. Yes or no? Right? So you're able to see n equal to 1, first shell, n equal to 2, second shell. Because I've told you, in the shell, you think of subshell and then the orbital. Right? S subshell will have s orbital. Right? Now, what you are having here is, you would have written here for boron, you would have written till now 2, 3. Did you write like that till now in your classes? Because it is in the first shell. How many electrons? 2. In the second shell, this is also 2 now. So it is the same shell, beta. So it will be 2 plus 1. How many? 3. So basically it is 2, 3. Then for carbon, you might have written just 2, 4. Yes or no? So 2 is for the shell. 4 is for the second shell. Getting it? Now here, nitrogen, you might have written 2, 5. Why? First shell, 2 electrons. Second shell, 5 electrons. Yes, we can write 2p3. Why we can't write 2p3, beta? We can write. Oxygen, you might have written 2, 6. You're able to see 2 and 6. Okay. Now, here, if you have understood, tell me about argon. For argon, what we are going to do, there are 18 electrons. So, first, you send the electrons. See, the capacity of 1s is only 2 electrons. 2s is also maximum 2 electrons. 2p, it is 6 electrons. 3s, it is 2 electrons. 3p, it is 6 electrons maximum, but we can always write 3p1, 3p2, 3p3. Progressively it gets filled up, right? Then you're having 4s. 4s maximum capacity is 2, but you can write 4s1 and 4s2, right? Then 3d maximum capacity is 10. You'll be starting off with 3d1 to 3d10, right? So 1s2, 2s2, 2p6, 3s2, 3p6. Are you able to see how many electrons? 10 electrons and here 8. And in fact, you would be writing something like this according to shell-wise sort till so far. What you might have written is, you might have written like 2, 8, 8. This is how you might have written for argon till now. Yes, you can never write 4s3 beta because S has only capacity of 2 electrons. Written? You are able to relate to that? Yeah, good. Very good. So I really appreciate that you are trying to understand certain concepts. You know, you're able to, kind of, if you're not able to understand, you are able to raise the questions, right? And it's always, it's better to ask. Unless and until you ask, we will not be able to solve the queries. And it's good. I encourage asking the proper questions, right? Now, when it comes to potassium, it is 1s2, 2s2, 2p6, 3s2, then 3p6. P is full now. After that, where the electron has to move? It has to move to 4s, 4s1. Are you able to see that? Now, for calcium, you tell me. Calcium, Rajendra should tell me. Rajendra, you tell me, I'll write it. Rajendra and Abu. Why I'm pointing out is, only thing is, so that whether you have understood or not, just to check on that. Okay. For calcium, what you will write? At max, see, never be scared of answering. At max, what will happen? Maximum wrong, na? But at least you tried. People are volatilized, went away. This is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? Okay. Now for scandium. For scandium, it is 21. Now I'll bring that particular, this diagram back. This diagram I'm talking about, okay? Half of the thing which I've written, because up to this only we are seeing, okay? For scandium, what you are going to write is, you are going to write 1s2, up to at least calcium, it will be same, na? Right? So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. After 4s, where the electron is entering? Electron is entering into 3D. How many electrons? You take count of it. This is basically how many? 2 plus 8, 10. Here also 18. 18 plus 2 is 20. Only one electron left out. So that will be 3D1. Able to see? Okay. Now for titanium, you tell me where I'll move. 3D2 it will become. For Mn, it will be 3D5. So it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. For Mn, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Right? Clear about this? Now the thing is, some of you might have felt that it is slightly on the typical side for understanding. Please don't, kind of give up on that particular thing. You must always try to understand anything, right? And for practice, what you can do is, those who were not able to kind of do now. So what you can do is, you can go through it again and you can basically practice on your own by learning the sequence, right? So later on, so I have given you a brief summary of how to write down. I cannot say that whether I'll be teaching that particular portion or not, beta. So whatever topic will be there, it will be taught. Don't worry about it. Okay. So this is the QR code. Please scan it. So electronic configuration, you have already learned about it, and this will definitely help in tomorrow's lecture, right? Not now, beta. Tomorrow you'll come to know better. Timetable will be shared with you, right? So that's all. So that's all, and I hope everybody had a good session here, right? And please revise this thing, okay? And I'm not giving any particular kind of homework at present because you've just understood some of the things. And if at all you really want homework, I'll give you homework. I have given you all those, S block, P block, D block, right? You remember their mnemonics and the symbol of the elements, right? And again, one more thing is, basically you can download the periodic table from iupsc.org. I'm telling you that. There is iupsc.org. This is official website. So from there, you can basically download the periodic table. And why am I asking you to download the periodic table is because there are certain typical names which are there, like Nihonium, Tennessee, right? So Oganesson. So basically you learn with the mnemonic your S block, P block, D block, right? Whatever I've taught you by writing it, right? Getting it? So tomorrow, basically, when I'm taking the lecture, we all are going to make the periodic table, entire periodic table by looking at that. Okay, clear about this, right? So thank you and have a nice day.